Great. Good morning, everyone. Thanks for joining this session. I see some more people joining in. So let's start. Thanks for being here live to the webinar part 3 about mioty backends. So you will see we will look into the mioty building blocks, explore mioty backend options. And for you being here in the live part, you can also ask questions at the end. So that's your advantage of joining live. And the webinar is also going to be recorded. So you can always watch it at the end and go through the slides after the webinar. So yeah, today we have Rafael and Rubén from LORIOT showing us some content about mioty backend. And we will even have a demonstration of the open source project mioty Go, how you can build your own mioty base station at home. So that's going to be real interesting as well. And yeah, if you have questions, there is a question and answer section of this Microsoft Teams webinar. Just ask them there, please, and we will go through it at the very end. So thanks for participating. And now let's get started with Rafael.
All right, good morning, everyone. Thank you, Misha, and welcome everyone to today's session. I'm Rafael Domenech. I'm head of product. I'm head of product at LORIOT, and today we're looking at how the IoT landscape is evolving towards a landscape where multiple technologies coexist, and we are going to explore LORIOT's hybrid approach a little bit as well, specifically how we have unified the part of the LoRaWAN network server and the mioty service center into a single cohesive tool, which we call the network management system, designed to give you like one consistent interface to very different but complementary technologies, which is the key here. So that's the general purpose of this. So what is this hybrid approach? What is the advantage? So we have the one who we have LoRaWAN, we have also mioty. These are the two segments or main components of this hybrid approach. In the real world, radio environments are really uniform. You might have thousands of devices in a clean rural area and thousands more in a noisy industrial plant. And LoRaWAN is clearly the market leader because of the vast ecosystem it has. But as you scale into high-density environments, interference, collisions, and so forth become a major obstacle for this chip-modulated LoRaWAN. And this is where mioty shines. And then because of the telegram splitting a single message into many tiny short bursts across different frequencies, it can survive the extreme interference. And with a hybrid network management system, you don't have to choose one standard over the other. You can deploy LoRaWAN for your standard smart city needs and mioty for the high density or critical industrial links, all within the same network structure. And this is a key point because this, as a developer, as a company trying to be future-proof to avoid the technology lock-in, you still have the options open. There might be some things where one protocol excels at, and some others where the other is the best option, and you are not forced to just pick one over the other. So what have we done? We've unified the architecture of both backends. We have this, what we call this dual engine backend, carrier-grade LNS, and as well as mioty service center. And so we've integrated these engines under one roof. And the NMS acts as the backbone for both, handling the LoRaWAN operations while simultaneously acting as the mioty service center, coordinating the mioty endpoints, base stations, mioty traffic. So what this means for your developers is the simplicity of this whole thing, right? You have one single cohesive platform where the data comes from a LoRaWAN sensor or a mioty endpoint. It uses the same output interfaces and the same message format. And you even have our integrated payload codec engine that handles the decoding for you. So if you just provide it with a simple codec in JavaScript, it can decode everything the same way for LoRaWAN as for mioty. So you have clear human readable data ready for immediate analysis in the same fashion. So you don't have to work in two different directions. You can just apply the same mechanisms to both technologies, right? So, scaling to millions of devices generally requires automation. I think that's pretty evident the more you think about it. And I think one key difference between LoRaWAN and mioty is how device management and traffic is handled at base station or gateway level. You know? The default behavior for LoRaWAN is to have the gateways automatically, let's say, forward all the LoRaWAN uplinks to the network server. You can, of course, enable some filtering depending on your package forwarder and so on. But this is a default behavior, basically. And on mioty, on the other hand, it requires the endpoints to be attached to any given base station for it to enable the traffic with the service center. Basically, you could see it as some sort of whitelisting. Only those I explicitly mentioned, those are allowed to communicate with my service center, or my service center can send downlinks to them. So in a typical mioty setup, the problem is here attaching endpoints to specific base stations can be a repetitive manual task, right? You have to click, you have attached every endpoint to every base station, and the more you scale, the more cumbersome this becomes, and the more of a bottleneck this can become. It's not the same thing to have one base station and 10 devices than having hundreds of base stations and thousands of devices, right? So here we introduced what we call the smart attachments to eliminate this bottleneck. So here you can just link your application, your endpoints, the grouping with a network of base stations, and the NMS automatically manages the propagation of the attachment commands. Right? This ensures that as you grow, the system handles the heavy lifting of this coordination. You don't need to be doing this manually, which you might do in a POC or in a development of a specific hardware. But for the actual use case, this automation is key to support mioty's massive capacity of millions of messages per day, right? But if you have to do it manually, it would be too cumbersome. So this allows your team to focus on the data rather than infrastructure management, because everything is handled automatically. The same way, in a manner as it would happen for LoRaWAN. You just enable it and you forget about the synchronization because the NMS handles everything. So, but then, of course, you have to choose how do you want to deploy. When you scale from this first hardware development use case POC that you're working on, you have to choose a deployment model, which is always about balancing cost and speed and control over your data, your infrastructure, right? And there are various approaches on how to host your network server or service center, but basically it always boils down to three. There's a free of cost public servers option with some limitations. There are managed cloud servers for, let's call them smaller professional use cases, and there are private server instances. And for those in the testing or academic phase, public servers like LORIOT, we use the term community servers, provide instant free access, but typically there is this limitation. In our case, would be limiting the number of devices you can registering, and you also have to keep in mind that you're sharing a server with hundreds or even thousands of other users. But for this initial step, it's typically one of the easiest ways in. Moving then to the managed cloud, we have the professional public server model, which you have your service level agreements, which is critical for commercial services. It enables a multi-tenant setup to manage your use case with your team, right? This is the next step as an evolution. And finally, organizations like national utilities or high security manufacturing, general enterprises, right? The enterprise private server is the gold standard. It's what allows you to host the entire system on your own infrastructure or in private cloud, providing you full digital sovereignty and the ability to operate in air-gapped environments even. But the trade-off here is that you have the overhead of managing your own infrastructure. However, it grants you the total control over the data flow and the security and so forth, right? It's always this trade-off between, okay, how much do I want to take care of the infrastructure that hosts the servers, and how much do I want to be able to control my data and who is sharing these resources with me, right? Especially when we move towards the last point with the private servers, there's always this different approach, whether it's in the cloud, is this a global distribution, or is it more like site-centric, on-prem, or even edge deployment? Now, where your data lives, it matters a lot, especially given ever more complicated data governance legislation and data security is always a concern for every company. So if you're running, for example, a chemical plant or a mine, you need an edge-centric deployment. You cannot rely on external internet for safety-critical alerts, and you need the lowest possible latency. Or maybe on the flip side, you're a global logistics or asset tracking company that requires the reach of cloud servers for your applications, where you can scale across continents without actually touching the server rack. No? There's a third option that is coming up, and so many sophisticated users are now trying to adopt a kind of hybrid strategy, keeping the core of the network on site for security purposes, but use the cloud-based management tools from the application side, let's say, to oversee the health of the devices, the use case, and so on. No? But this is the third option that is becoming more and more interesting for many. But typically, these are the two options where, as a company, you are trying to define, okay, where is my focus, right? Am I aiming at being locally secure and uninterrupted, or do I need to spread out and be able to connect from everywhere? No. So there's always some small operational considerations to have. For example, the security, so operational success depends on reliability and visibility, and security must be baked in. With TLS, with translated encryption for all data transit at release 1.2. You need to have KPIs for all your resources. You need to be able to see a traffic history. What was the behavior over time for these gateways, base stations, endpoints, LoRaWAN devices, right? You need all of that. And well, even in the case of LoRaWAN specifically, some of the gateways support the spectrum analysis, which you can use through the LORIOT NMS. Many base stations in mioty also have a similar option. So this is also good to identify any odd behavior on the radio spectrum. And it's also very important that you can remotely control and manage your gateways and base stations. In our case, via the dashboard, you can do that. You can remotely connect, you can see the logs, and you can reconfigure as necessary, because this allows you to save a lot on site visits, right? This is a very important thing to consider, because the ease of managing your hardware remotely versus having to send people out onto the field maybe several times just for troubleshooting or monitoring, that can get like really expensive by comparison. So let's look at this in practice. What are some real world use cases that both LoRaWAN and mioty have something to say? So water metering is basically one of the biggest targets in the IoT market, metering in general. And so while there are many LoRaWAN metering devices and use cases, for example, this is an area where mioty absolutely excels at. It's a technology that is basically the best in class for this sort of deployment, right? So we see in factories, we see mioty sensors monitoring machine vibrations right next to heavy electrical noise that would drown out other signals. We've seen LoRaWAN vibration sensors in fleet management used for predictive maintenance in factory as well, right? And for safety, we've seen mioty endpoints for lone work alerts because this telegram splitting ensures the emergency signal gets through even if the frequency band is blocked, ensuring the authorities can be alerted and the safety of the work is not compromised. And you've seen this also similar use cases with LoRaWAN for worker protection, where workers can be tracked, that they are not living into dangerous areas and so forth, kind of a geofencing with LoRaWAN as well. So there are many use cases where both technologies sort of overlap, but they have their very specific use case where they excel at. And this is something that we want to emphasize, because this is the key to a successful use case, not the technology, but the solution it provides. Huh? Okay, so real quick conclusion and summary. Wrap up LORIOT hybrid approach is about giving the freedom to scale. By unifying LoRaWAN and mioty, automating these attachments, for example, and offering deployments, the range from going to community cloud to sovereign private servers. You have for this backbone for the massive IoT. So I can only say, if you're interested in trying out mioty in general, just testing out our hybrid approach, I encourage you to try it out. Visit our community service, for example, register an account for free, experience this in firsthand. But definitely, you have to get your hands dirty and try a little bit, because you will see it's a fantastic technology. So at this point, I would like to thank you guys and move on to Rubén's part, who will be talking about mioty Go.
Yep. Thank you, Rafael, for your presentation. As Rafael said, I'm Rubén. I'm working as an embedded developer in LORIOT, and I'm the one who is going to handle the mioty Go live demo. But first of all, let's have an overview about what mioty Go is. So mioty Go is basically a mioty-based station, which is developed by LORIOT for Mioty Alliance. And the purpose of this project is basically designed for testing, development, sandboxing some environments, and make an approach for people to get closer to this technology. So it's think to be run in a standard Linux environment. This basically, we got two options: is running it on a PC, on a development board like Raspberry Pi, which is the two architectures that we are currently supported, and it's also using an SDR Play receiver, which we can support RSP1A and RSP1B. So it's like accessible hardware for everybody. With mioty Go, we are able to handle uplinks up to 10 devices, to 10 mioty endpoints, and of course we are following the BSSCI standard protocol in order to make the communication with the service center using the TLS certificates, and of course we can set this mioty Go project in different regions, so we can handle different profiles or frequency bands with this project. So yeah, having this overview, I will say let's start with the demo. In this live demo, I'm going to make the full setup from installing the software. This time I'm going to install it in my laptop until we got traffic flowing throughout the whole setup. So I'm going to present my screen, and then we can proceed with the demo. Okay, so here, mioty Go is of course publicly available, so everyone can access to our GitHub repository, which is LORIOT/mioty Go, and basically here is containing the whole software that you need to install. It also contains a README, which pretty much the whole explanation about what it is, which hardware we need to use, how to install it in the device you choose, and of course a guide about how to set how to make the whole setup in the service center, which this time I will use a community server from LORIOT EU3 specifically. And yeah, here are the whole overview, all the steps, step by step. So just to make the setup really easy. You will see that it's not difficult to have the setup ready. So let's proceed with it. In order to install the software, what I'm going to do is I'm going to download the latest release. This case, I will be installing it in my laptop, as I said. So I'm going to copy the link and I'm going to download the software. So here I got the link. So I'm downloading. I don't know why it's not downloading. Okay, let's try another thing. So mioty Go, and here I'm going to say, okay. Now we got it. I'm going to give permissions to be executable. And first step for me, it's gonna be install the software. So as you can see, the software is being installed. And at this point, I got pretty much the mioty Go already installed in my laptop. Now, in this stage, what we need to do is, okay, let's say the base station it's kind of ready, but first we need to communicate to, or we need to register our base station in the community server, in the service center. For a service center, as I said, I'm using u3.lorio.io. Once you register in the server, you will see this screen. And the very first step is to create a network. In this case, it's gonna be a new mioty network. The name I'm gonna give it is mioty Go live demo, for example. So now I got the network for mioty already created. So once this network is created, we need to add the base station, because in a network we can add different base station. In this case, I'm going to add only one. So I'm going to press the add base station button, and the only thing we need for registering a new base station is the EUI. This EUI, we can find it when we perform the installation. We can, if we read the logs here, we say, okay, our base station is successfully installed, and here is our unique identifier. Let's copy it and let's paste it here. So at this point, my base station is successfully registered. So in this point, we got the mioty software in our laptop already installed, or laptop or Raspberry Pi. This case is laptop, but as I said, it can also be installed in a Raspberry Pi. And our service center knows which base station it's gonna connect. As I said before, as I mentioned before, we are using TLS in order to perform this connection, to make it secure. So in order to do that TLS connection, we need to set the certificates. For setting the certificates, we basically need 3 certificates: our CA certificate and the TLS keeper to perform the TLS connection. First of all, I'm going to copy the CA certificate, which is the root CA. And as you can see here, if we follow the instructions, here we say, okay, we need to fill a certificate content. We also got the path to do it. So the root CA certificate, it's going to be stored here. So let me open this file. And here I'm going to copy the content and paste it and save this. Now we are going to do the same for a TLS keeper. So let me open this file. I'm going to generate the certificate, copying the certificate and pasting it here. And the same for the key. So I'm going to copy the key and paste the key here. Okay, perfect. So now at this point, what we got is, of course, the gateway, the base station is already registered. We communicate to we set the certificates in the service center and also in the base station. So now we are ready to perform the connection. In order to start the mioty Go software, here is the command. So I'm going to copy this. And we need sudo privileges. So here I started the connection, and reading the logs, we can see that we are connected to the service center. Then if we go to the UI, if we refresh this, we see that our base station now is connected. And also, as we can see here, I'm using an RSP1A. It's here. I got it connecting using a USB cable, and it's also configured. So in order to show traffic, what we need to do in our server is to create an application. In that application, we are going to hold our mioty endpoints. So let me first create the application. I'm going to give, for example, this name, mioty Go test. And our application is successfully registered. So now, as I said, I need to enroll a new mioty endpoint. In order to do that, I'm going to register what it's going to be a dummy endpoint, let's say, to generate some on-demand data. So I'm going to give, for example, these numbers. So now I got my mioty dummy endpoint, in this case, already created. So at this point, we got the network. In that network, we got the base station register. We also got our base station software, which is mioty Go, running and connected to the service center. We got the application and we create an endpoint in that application. So what we are going to do now is, in order to make the base station know, okay, you need to forward data from this endpoint. So we need to propagate the smart attachment to the base station. So in order to do that, here in the application, I'm going to select the endpoint that I just create. And as you can see here, we got our base station, and we are going to propagate the attachment to that base station. Here it says the attachment is complete. Let's check the logs. And as you can see here in the mioty software, we can see that the attach propagate has been received from the endpoint that we just created. So at this point, we should be able to forward data. But first of all, I'm going also to show you how we can set, in this case, an output for all this data. For this demonstration, we are going to use a WebSocket output. So I'm going to, this is created by default when you create application. I'm going to copy this URL, which is basically the WebSocket that is listening, is the token is already embedded on it. And I'm going to open it in this online WebSocket tester just to show you how the output will look like. So I'm going to paste this here. And as you can see, the connection is established with that endpoint. So now at this point, I'm going to show these logs, and I'm going to forward. I'm going to send some dummy data just to be able to see what is happening here. So let me quickly create an uplink and send an uplink. Okay, here. Now we got the data received from the endpoint that I just created. And as I said, I'm sending dummy data. And we are able to see how this data has been collected first by our service center in the application. If we go to the endpoint, we can see we received some dummy data a few seconds ago, and also in our mock WebSocket viewer, we can see that from the EUI that I just create, we, following the mioty protocol, we just received some dummy data. And so yeah, as I said, now I made a demo with only one device, but you can perform a setup with mioty Go up to 10 devices at the same time. So this provides the capability to perform some sandbox environment, to test the technology, to get an approach, to play with our service center and our server, and see how the mioty technology could work, and perform some demos of application that people got in mind or wherever. So yeah, that's basically what it is. And also I'm going to show here in the network how the mioty base station, mioty Go in this case, remains online, and here some logs about it, and yeah. So that's basically the demo.
Great, thanks a lot for showing this. That was really interesting to see how fast it can also be to have a working demo running. Great, thanks a lot.